go? How did my map go? Yay, nay, okay. Right? So what does my map do? Who can tell me? Who wants to tell me what it does? Like in a nice, clean phrase. Yeah, Deja?
My map is basically going to take that array of numbers and spit back out another array of numbers, but for whichever mathematical thing you want to do to those set of numbers, it will do it for you.
Okay, so that's pretty close, right? Does it have to be numbers? Does an array have to be numbers?
No, it doesn't have to be numbers. Like,
Okay.
it takes,
Well, this one.
this one happens to have.
Well, actually, this one. So these are 3 different problems.
Oh.
Right. So we're really close. Deja's like almost completely correct, except for she's identifying the array as just having numbers. Right? It's an array that loops through it, takes every element of the array, calls the callback on that element, gets that return from the callback, pushes that into a new array, and returns that new array at the end. Okay, so let's see what that kind of looks like. That's like what my wife would say. All right, so we say array dot prototype dot my map. Right, we have to write this in ES5 style because we can't extend or like build off of the array class in ES6. So this is how you do monkey patching. It's called or duck typing, I think they sometimes call it. All right, this takes in a callback. We talked about, and so we said we need this new array. So I'm going to go ahead and say let result. Set that equal to our new array. And then we have to make this loop. So we're going to go, okay, for let, well, I could do, no, I'll just do I, right, why not? I equal to 0. Well, I is less than, what is the instance?
It's this.
It's this. This is it, right? This dot length. This represents the instance that we're calling this method on. And we're saying I plus plus. And then we are pushing into our new result. So we'll say result.push. And this is where we'll call that callback, right? This is where the change actually occurs. So we'll say callback, we'll invoke it, we'll put this at I. I can pass other things if I want. I can also say I, because like that's like an optional argument to the real map. I think it also then goes like this. Forget what happens next. So this, whatever, it doesn't really matter. I'm just going to leave it at that for now. And at the very end, we can return our result. Shall we try it? Okay, let's say let array equal, I'll say cat, dog, this is for you, Deja, and bird, right? I should have stayed consistent. Okay, anyway, and we will say console.log, whatever I get back from this, which is going to be bird dot my map, and this just takes in an element and returns the element dot to uppercase. In Ruby, it's just called uppercase. Anyway, just so you know, in case you just want to learn, in case you're keeping a little Ruby log. Oh, that's weird. Hang on. Not bird? Yeah. Thank you. And this should be node, yeah. Not whatever that was. Oh, freaks out. Some kind of error. Looks like one of those, some kind of import thing snuck up at the top. Really not sure why that keeps happening. It's some shortcut that I somehow keep accidentally hitting. This is in the Unit 1 review, just so you know. That's the file I'm working in at the moment. Try again. It's going to work. Cat, dog, bird. Questions on my map? All right, cool. So let's hit the next one, yeah? Next one is filter. So the high level idea of what filter does. Who can tell me what that is in a nice, as clean of sentence as possible? Yeah, Marvin, you want to give it a shot?
Filter also returns an array and applies a callback to each element as it iterates through the array. However, the return new array, the elements in that array would be whatever is true, depending on what your callback is.
Yeah, sure, right? So every element in the array is still acted on by the callback, and whichever elements for which that callback gives back a truthy return, that element is added into the new array. Right? Yeah, Marvin, great job. So we're going to say array dot prototype dot my filter function callback. I'm just going to call it CB because I saw most of you just do CB, so I'm going to write short as well. And this again, has a result, and then we're looping. I is less than this dot length. This being what? Yep, representing the instance, right? I plus, and then we can say if, and this is where we have to check if that callback has a truthy return value. So if callback this at I, then we want to push, we want to add to our result this at I, right? This is where I would also pass in my optional I up here. And then at the very end, we can go ahead and return our result. Questions on that? Yeah, Shia.
What are you saying when you do the callback on I or just I?
What do you mean by on the callback on just I?
Like how we have this at I and then
So this is the element that I'm passing into the callback, and this is the index that I'm passing into the callback. Right? This is not required, right? I didn't like, but if you want to make it more like the real filter, right? Because all of those have an optional I. Now we have it. And I can show you what I mean. I could say, okay, so we'll say let array, and we have 1, 2, 3, 4, 5. And I can say log array.myFilter. Okay, and this takes in an element, but it also could take in an I, right? It takes in both, like that. So now I could filter something based off of my element, or I could filter based off of my index as well. So I could say like, hey, if return. So if I wanted only the odd length things, right? I could say I modulo 2, because if it's an odd index. So this will give me back 2, 4. This will interestingly give me back every even element. Right, that's like the real filter. Or I could do the elements. Say this. Or L modulo 2, right? And this would give me back all the odd numbers. So it's just an optional I. That's all that's doing. Questions on the filter? Britt. The map or filter? Yes. Oh, okay. Any questions about it? Sorry, here. Yeah. The 0 is a falsy value. Yeah. Nice catch. So just to repeat what Jay's deducing, he says, the reason I'm getting back odd numbers is because L modulo 2 either gives us a 1 or a 0. A 1 is a truthy value, 0 is falsy. Hey, what are the 7 falsy values of JavaScript? Somebody give me one. NaN, yeah. Rob? 0. Kong? Undefined. Kelvin? Null. Negative 0, yeah, okay, I take it. What else? Empty string? False, yeah, perfect. All right, we got it. We can still do it. I like it. All right, let's move on to the third one, and hopefully the most challenging one because it's the only one we haven't seen yet. Okay, so write a function that takes in an array of numbers and a target number. Return an array of all the paired indices that add up to the target. So what's the overall approach that we would take for something like this? Yeah, Jack.
You need to loop through twice because you have to compare each element of the array to each other element of the array. Or it means add them together and compare.
Okay, so Jay says we can have 2 for loops so that we can look, here, so the negative 7, 0, 2, what is it? 3, 7, 8, 3, 7, 8, negative 2. And we have that goal of 0. Is there another color? I know we're running low.
There are a bunch in the
Okay, well. It's okay, I got it. Alright. So, we can have 2 for loops, right? If we iterate through this and one is nested inside the other, we'll have I being like 0, right? And we'll have J at 0. And so J will continue to increment, right? So J will become 1. So they start off here together. Then J will become 1. We'll do some math. Then J will become 2. Get moved over to here. Then J will become 3, so on and so forth, right? So it ends up going like this. Does this pattern make sense? It's going to keep, every time I increments by 1, J will then have to do all of them. Right. So the time complexity of this is considered n squared, just so you know. I know we haven't really learned about time complexities, but just if you're keeping notes in your head, that's n squared, or quadratic time. So let's go ahead and write this. So we'll say const find indices, and this takes in an array and a target. And the goal of the output is what? What's the output look like? It's an array. It's an array of arrays, yeah? So what do we need to make? What's the first thing we need? We need a new empty array. So we're going to say, oh, thank you. Whoa. I love it. Give a mouse a cookie. I'm going to be asking for all kinds of stuff. Thank you. Do we have more erasers? I'm just kidding. It's a total joke. Way to go. Thank you so much for those. Yeah, I don't know how those all got away. Okay, so we'll say let result, and we'll have an empty array. Oh, for people watching the video, Rob just came in with a bunch of markers. Hats off to Rob. Okay, so we've got our for loop. So we'll say for let I equal to 0. Well, I is less than array.length, yikes, .length, I plus plus. And then we got to do like this, okay, this nested loop. So for let j equal to 0. So if we do this, j is going to be at 0. So we'll see what happens when we do that, though. J is less than array dot. Yeah, if I could just, my hands just work. I'm all over the place. J plus plus. And then we have to do this condition to figure out if they add up to each other, right? All right, well, if they add up to the target. So we can say, like, hey, if array at I plus array at j, right, these are the actual elements. If that's equal to our target, let me just make sure that these do math first before the comparison. So if that's equal to the target, then we're going to say result.push this I comma j.
So I also added in one more condition to make sure that I and J are not the same number.
Okay,
So that it wouldn't.
just give me, we're going to get there, yeah. Because you're totally right. I just want us to see the steps. This is a normal debugging error. Okay, and then we'll return our result. I know some of us might know that this is wrong, and they might know why it's wrong and all that, but are we following up to this point? Does this logic feel somewhat like it makes sense, yeah? So let's give it a shot. So we're going to call find indices, console.log, and we'll say find indices, and we'll pass in nums and target. And we should get some interesting results. Okay, well, that's not what I was expecting. Why did that happen? Oh, I'm not in the bottom, right? There's the first mistake. I returned prematurely. Okay. So we're getting back this data. What don't we like about this? What do we notice? What are some things we notice? Isaiah.
It's the same parts as reverse. Like they're the same indices just in reverse order.
Okay, so what he's saying is we have like a 6-2 here and a 2-6 here. Those are the same indices, right? So that's not really a different answer. It's the same answer. There's a 4-0 and a 0-4. So there's some issue there. Well, but we don't have a 1-1-1-1, so I don't know. What else do we see? What's the Jay?
1, 1 can't key into the same part of your one array twice.
That's right. So Jay says we've got 1-1. So we have an indice pair that's pointing to the exact same indice because it's saying 0 plus 0 is 0. But that's not really a pair in the array. That's just one element in the array that happens to be the same as the target, right? So, okay, so we can add to what Jay said. Well, we can conquer both of these at the same time. But Jay says we can also add an and I does not equal get. Because now we won't have indices that are the same. Okay, so now we're getting closer. Now we're more on the Isaiah problem. So that's because when we're doing this loop, right, we're following this path where this keeps iterating, like kind of in like this downward angle, while the other one keeps starting, and then it starts again here, right? But okay, so we're like, all right. And then here, but these have already like been matched before, right? Like we've already had one where the red is there and black is there. So why do it again? So we can have a better starting point. So instead of starting at 0 every time we're in the inside loop, right, we can make a minor improvement and start at I plus 1. And then we don't need this because I and j will never equal each other. What? So then we get the answer. So to answer Ashia's what? But if we keep starting at 0 even though when I is 0, it checks everything at I being 0. Right? It's seen it when I is 0, j is 0. It's like done that. It's done that I is 0, j is 1. So this way, otherwise, every time we move I and j starts back at 0, there's doubles. We'll have checked every combination with each other twice. But if we started at I plus 1, we'll only check every combination one time. Good, Doug.
Are you able to do that with for each?
Well, yeah, I could do a for each and pass in my optional I.
How would you like to inserting it?
Oh, yeah, I can't. You're right. I don't think so, no. Yeah, it wouldn't be the right move.
That's
Yeah.
where I started. I was like, oh, for each, you're gonna loop it. And then I was like, I need both numbers.
So the time complexity of this is still technically n squared, just so you know. I'm going to go ahead and show us another possible route we could have taken, which is actually a better solution. And it looks a little bit something like this. So we could say like const find, and this is more to show like that there's more, like we've seen more than one way to do it, but all the ones we saw earlier, wow, this is not going to last. We're all like similar time complexities, but this one is a bit different. So this is going to be 2. This takes in an array and a target. And so something we can think about instead is instead of keeping like a random check, we can keep track of things we've seen and what we need. So what do I mean by that? Let's go back to our array here that we have. Get rid of all these lines. And so if my target is 0, and I look at -7, what do I need? I need a +7, right? How do we get that number? How do we get that +7? How did we do that? No, but how did you mathematically get that we were looking for a +7?
Absolute value of 7.
I don't know. Let's think about it a little bit more.
Oh, the difference between 0 and 7.
The difference
Or
between
0 and -7.
Yeah, so the difference between our 0 or our target and our current element is what we're looking for, right? So 0 minus -7 ends up giving you a 7, right? I think that's the math, yeah?
It's just the distance from 0 basically.
No, it's the distance from our target. The target does not have to be 0.
Well, I mean, I just meant this.
So if we keep that in mind, right, we say target minus element. This gives us what we're looking for. Right? Can we agree on that? All right, so if we know that, we can keep an object. I could say, hey, I'm looking for the number 7. And the pair of that occurred at the index of 0. Right? Because this is where its match was. Look at, just bear with me. We look at 0. What does 0 mean? It needs another 0, right? So 0 matches, and the 0 that we just saw was on the 0, not the 1, the 1's first index, right? These are the indices. Okay, so let's continue. We'll see the 2. 2 tells us we're looking for, right? Target minus 2 is -2. So we're going to look for a -2 and point that at the current indice that we're on. We move over to 3. We're looking for a -3. Point that to the indice that we're on. Then we get a 7. And we can key into our object every time and check, And we go, oh shoot, there is a 7 in here. Right? So now if there's a 7 in there, what do we add? We grab the indice out of the object, and we look at the indice we're currently on. So now we add this 0, 4 into our results. Really? Okay, interesting. So we no need to add it here because we've already found one. We move on to the 8. 8 tells us we're looking for -8, yeah? And that's happened on the 5th indice. We move on, we see -2. Oh, we actually have a -2. We had that at the 2nd indice. So now we add the 2 and whichever indice we're currently on, which is 6. So we can do this in one loop using objects with their key value lookup. All right, that's kind of a clever way to get around it. Significantly better time performance, like significantly. What does this code actually look like? Let's take 10 minutes and see if you can translate it into code first. Okay? Yes.
This one. Yeah, it just gives me like, it gives me like a blank box. Nice catch.
Thank you.
You know, it's the little stuff. Oh, to get the number.
Yeah, so that it's like, so that's like showing,
When you push that
so
out.
when it's -7, it's showing what it is, we find something that matches.
The target is 0. So which what pair of numbers is the array? What numbers do you have to use?
To get that first edition thing in order to compare it to minus, yeah, to minus.
I'm totally kind of understanding. Yeah. Yeah. For the first one. Alright, the one that what are we what are we serving and how we serve.
We're using
So zero. Team is six. That's the next on there. Okay. Yeah, it's a twist.
So I feel like I'm missing stuff. This is sorry.
It's still, that's essentially, this is all supposed to be like one, and needs to be using an object. So let's say that brings off. Okay, that's their new skirt. The element is get rid of. Are you worried about the false zero?
No, look away. See if I'm doing something that's not like this.
So you want to check first. If it's not in there, then we're going to add it. Otherwise, we're going to add it to our solver. First, we're going to do it here. See if it's it doesn't. Seven else. Well, we're looking through it only one time. So we're starting here. We say, okay, is this in our searching object? No, it's not, right? So what we do is we find the math they're looking for, put it in, assign it to the indice we're on. Move on. Is zero already in there? No. So we're going to put it in, put it at the indice. There's two in there. No. So we're going to put what we want to look for, put it at the indice we're at. Move on. 3, same thing. Get to 7. Is our 7 already in there? Yes. So instead of adding to it, we'll just take the indice, the current indice we're on, and we'll push that into our result. Right. Move on.
So if it does have that property,
We just-
then we just take
That is what that key does.
Yes.
Push it along with
want to do something that doesn't.
Let me work.
Unless if it was an array, you know, plug in the key that you want to check.
So you could not resolve this. Sorry.
I mean,
Early birds?
Yeah.
And then you still have to resolve it.
Yeah.
I not that's if object. It's not being result of the fact. And then you just return the result.
Yeah. But I feel like I might be on my round.
Yeah, so you're gonna.
I did that.
There needs to be a second comparison.
Yes.
I've gone over everything. What's up? You got it?
The rest of the things.
You don't want the indices that are to be certain,
I mean,
which we figured out by doing target. You want the value to occur. So a little bit. That would be a really good one for that. All right. Let's.
How do you say like in the like question, how do you say like target minus element without having to call the element?
I create a variable. No, you can call the element. You'll see. I'm gonna do it right now. Clap your hands once if you can hear my voice. Thank you. Clap your hands once if you can hear my voice. Thank you. Thank you very much. Henry, is that the one for running? Okay. Let's talk about this. This one's a lot harder. How did this one go though? Yes, no, nah. All right, yeah, right. This one's like a little bit of a jump. If you felt good on the double for loop, that's great. That's where I expect you to be at today. If you had trouble with this one, that's okay. I wouldn't like expect that yet. We're like still pretty new. Definitely learn it though, and like, right where we are today isn't where we want to end up. Right, it's just where we are today. So, like in an interview, you would want to talk about the like the double for loop way, but then you would want to probably implement it this way because it's a faster speed that it runs, which we'll learn more about later too. Right, so it's hard to kind of like really worry about writing efficient algorithms when we haven't even learned about big O. Yeah, right. So don't sweat it too much. So we'll have our result. So it should start off pretty similar. And then we can let our like searching object. Right? I don't know if that's the best name, but I guess it's close enough. And we talked about looping through our array. So we'll say for let I is at 0 while I is less than array dot length I plus plus. And so we said as we loop through it, we're going to get what we're currently looking for. So I'm going to go ahead and say let goal, I guess I'll call it for now. And I'll say that that's going to be my target minus my element. So array at I. Right? That's target minus element is what we're looking for. That's the goal. First thing we have to check is, does it exist in our searching object? So I'll say, hey, if searching at goal. So if I leave it just at this, we'll see. Well, we'll see it in a minute. If searching at goal, so if there is a key there with a value, then we're going to push this into our result. We'll say result.push searching at goal and our I. Else, we got to add that goal to our searching. So I'll say else searching at goal, and this should equal our current index, or our I. And at the very end of this whole thing, we can go ahead and return our result. So there is going to be a small bug, and hopefully we'll get a chance to see that. Find indices 2. Let's save it. And when we run it, well, that's a bigger bug than I expected. What?
That's what happened.
Okay. What you saw? Do you know what you did?
Still, I was hoping that it was figured out.
Huh.
The same thing. Minus 2.
So target. So we had target minus element. If searching at goal, we're going to push that in. Else searching at goal is equal to I. And we're getting back an empty array. Fascinating. Any ideas? Well, okay, so the first thing I'm going to note is I'm going to say, like, hey, one of these keys is a 0. I know that. My 7 points to a 0, right? 0 truthy or false?
False.
Okay, so knowing that, searching at goal, so if I did searching at 7 at some point and got back 0, we would still go into our else, because we'd be getting back 0. So I am going to change this to be not equal to undefined. So this means I have a value in there. The zeros are okay. But for some reason, something weird is still happening. Interesting. All right. Well, that is this. Is that what you mean? Or do you mean like throughout?
No, in searching. You can also love searching to see if there's anything in searching.
Sure. Sounds like a good start. We'll console log searching. Let's see here. Okay, so we're adding stuff. And it looks pretty good. Looks like what we wrote on the board.
Or you're checking if target minus array I exists. You want to just check if array target at array. I mean searching at array at I exists, not target. Because if
Oh,
we're
yeah.
checking if 7 exists or negative 7.
That's
we're
right.
checking if negative 7 exists or 7.
That's it. And then this is array at I too, yeah? Okay. Nice, thank you, Isaiah. So, just for anyone who didn't follow that, when we're putting in our goal here, what we need to check is if the element we're on is currently in searching already, right? So when we had -7, we checked if -7 was in here. Since it wasn't, we put what our goal would be someday. So then when we did get to our 7, we had to see if that was already in there, if that had already been a goal that was previously set. So we're still setting our goal here, but in here we're checking if array at I is not equal to undefined and pushing that indice into our result array. Questions on that? Yeah, Marvin.
I tried to do it with a for in loop. Is that possible?
For in loop? Yeah. It would be the same thing as this. It wouldn't be possible with a for of loop, though. Not that I can think of. Any other questions on this? All right, cool. So, for the rest of the day, right? So here we are. So we had 20 people who said they do want a hangman walkthrough. 4 people who said they did not, and we have a series of people who didn't vote. So, okay, so first off, we all need a break because we've been sitting down. We should move around. So let's take a break till 3:40. If you don't want to watch a hangman walkthrough, you don't have to. You can go study. You can work on whatever you need. There's enough people that I'm going to do it in this room. So if you don't want to, you could go in the flex space or one of the meeting rooms or whatnot. If you do want a hangman walkthrough, you'll come in here. Okay? Thank you.